Hey guys, welcome back to another Tumor Teaches. Today we're going to go over sig figs, unit conversions, uh, and conversion factors. Um, we still have a little bit more to do before we start discussing some of the interesting chemistry stuff behind it. So quickly, we're going to go through a quick review of sig figs, scientific notation, and exponential notation. You should be familiar with this stuff by this age, but it's always good to do a quick review. So, um, in life in general, you're expected to either write in decimal or scientific notation. Uh, However, this exponential notation stuff is extremely useful, um, at least in the intermediate workings of your in the intermediate process of your work. Um, Scientific notation is just um, a single digit number times 10, a coefficient times a base to some power. Wait a moment. Why is my Okay, my headphones just disconnected there. Whatever. Sorry about that. So scientific notation is a form of exponential notation where the coefficient has to be at least 1, but less than 10, and the base is 10. So this number here can be between 1 and 10, but it can be between 1 and 9. It can't be 10. And then you have times 10 to the something. And we use it to express really big numbers and really small numbers. Um, if the exponent is negative, we have a really, really small number. If it's really big, if you have a really big number. So, for example, so that's sort of that. Pause the video here if you want to try some of these for yourself. Feel free to, but yeah, I won't. I might do this one here, just so you get the idea. So here, the decimal point is here. You move it 1, 2, 3. So this would be 2.3 times 10 to the 3. You're going to have to forgive me here for not having the best sort of math. So, right. So that's there. Just as an example here. For sig figs, it's a measure of all the certain digits and uncertain and the location of one uncertain digit and a measurement. Um, this will make more sense when we do topic 11 later on. But for to determine if something is a sig figs, if it's not zero, it's a sig fig, no matter what. If it's a zero, it depends on where it is. If it's not a placeholder and does denote the location of the uncertain digit, then they're significant. Otherwise, they're not. So, for example, here in 152.00, there are 5 sig figs. These zeros here count because they denote the level of precision in the number. So here, this is the uncertain digit, whereas here, since this is the last digit, these two zeros here aren't significant, and the easiest way to determine if something is significant or not, switch it to scientific notation, because the base here is always reported to the accurate number of significant figures. A bit of an ambiguous case here is this one, 5200. These could be placeholders, these could be denoting the uncertain digit. You cannot write numbers this way. You have to switch it in, you have to either switch it into scientific notation or change the units on it. So for example, you can report 5200 meters as 5.2 kilometers or 5.2 times 10 to the 3 meters. Uh, in experience, most people just tend to switch it to scientific notation. However, this is a good way of doing it too, and in some cases you might actually prefer it. Because I don't got all day, I'm just going to do the first three here. So for the number of sig figs, just pause right now if you want to try it. Alright, presumably you're now back after having paused it. So the number of sig figs here is, we have no zeros, so that's just 3. Here, this one, we have a 0 here, but it's sandwiched between two significant digits, so that's also significant, so also 3. Lastly here, this 9.80, if we switch it to scientific notation, it would be 9.8 times 10 to the minus 3 amperes, so that would just be 3. Uh, uh, so that should cover your sig fig reviews. Rounding rules. Less than half, round down. More than half, round up. If it's exactly half, you abide by the even rule, and then there's that. When you add or subtract, you want to. So when we do operations in science, we tend to report things to the correct number of the lowest number of sig figs or decimal places, just so that we can show the reader of our reports how accurate our data is. There are different rules for adding for each operation, so please do listen. When we add and subtract, we aim for the least number of decimal places. So here, for example, this has 3 decimal places, but this one only has 1, so therefore we only report our answer to 1. Same case here. They both have 2 decimal places, so we report it to 2 decimal places. However, when we're multiplying and dividing, we report it to the lowest number of sig figs, as the lowest number of sig figs given. So this one has 2 sig figs, this one has 3, so therefore our answer is only allowed 2. This one has 4, this one has 3, therefore you're only allowed up to 3 sig figs. And when we square it, remember squaring is just multiplying by itself, so you're only allowed to report it to 2 sig figs, do the squaring, then round it off to 85. If you have a multi-step calculation, pretty simple. Just round at each step. This should be reviewed to you by now. I'm not going to go through any examples. I might do like another video separately to just denote that sort of stuff. So here are some SI prefixes. Be familiar with them. However, these are on your data booklet, so I wouldn't worry too much in terms of memorizing it. Right. The last thing I want to talk about here, and it's probably the most useful thing that you'll ever come across in your education, is conversion factors. Now, what is a conversion factor? A conversion factor is a fraction involving 2 numbers with different units, which, think of it, that is equal to each other. So it's equal to 1. So, for example, if we converted 254 centimeters into meters, well, I happen to know that there are 100 centimeters in a meter, and the way you write the fraction is that you write it in such a way such that your units cancel out and you get the units you want. So for example, how do you know where to put the centimeters and the meters? Well, if I put it on the bottom, that means this centimeters here in the numerator will cancel with the one in the denominator, and we won't have centimeters anymore. The idea is similar for non-metric conversions. You just have to be told which is which. So i.e. a foot is 12 inches or a kilogram is 2.2 pounds. You have to be told that in the question. And yeah, you could also have a string of conversion factors such that you have, so for example, convert this into milliseconds. You know that there's 60 minutes in an hour, 60 seconds in a minute, and 1,000 milliseconds in 1 second. So we can cancel out the hours here, then the minutes cancel, and the seconds cancel. I'm only going to do 2 examples here just to get the point across. However, if you guys want another video on it, of course I'd be glad to do like a separate video, sort of like a video worksheet, I guess, if you will. So if we head over to the second screen here, let's convert here. Let's convert 12 inches into centimeters. Now I happen to know that in every 12 inches there are 30 centimeters. Let's write it in a way that's a bit more. So I happen to note that. So I'm going to start with what I have, so 12 inches. And then I'm going to write out my fraction like this. You can use square brackets, you can use curly brackets, it doesn't really matter. But the important thing here is that how do we know where the inches goes? Well, we know that these are units in the numerator and we want them to cancel, so in order to do that, we put these in the denominator, and then by sort of process of elimination, we have to know that the 30 centimeters goes on top. And then when we multiply it out, we get these inches cancel, and it also just happens to be that those 12s cancel, so we also get 30 centimeters. Alright, what if I wanted to convert 2 kg into pounds? Well, I happen to know that a kilogram is 2.2 pounds, I think. So if we write out our conversion factor, again, we want to write the fraction in such a way such that the units here will cancel. So 1 kilogram, 2.2 pounds. And then we notice here how lovely the units do cancel out, and we just multiply 2 times 2.2. We just multiply with a fraction essentially, and we get 4.4 pounds. And yeah, that's it. Thank you very much.